Okay, let's see how you did on these two problems about finding the conjugate acid-base pairs with the Bronsted-Lowry theory of what an acid and a base is. So here we go. So when you look at this one, maybe you already knew that hydrochloric acid was an acid. Okay, well, let me get a marker here. So maybe you already knew that this one is an acid, but let's say that you didn't. Okay, let's say you didn't know off the top of your head that that was hydrochloric acid, but you did recognize this one. Okay, that right there is a definition, our Arrhenius definition of what a base is. Okay, so that would help you identify this one because of course they're acid-base pairs. Okay, acid. Okay, so what does this one look the most like? Well, it doesn't look like chlorine. It doesn't even have that element in it. So right here is one pair. And here is the other pair. In fact, chlorine is in this species right there, so we can tell that that is the other one. So, since this one is an acid, you'll have your conjugate base right here. And since this is a base, you'll have a conjugate acid over here. Okay, so that will help you identify those. Now let's also think about this the way we're supposed to think about it by definition. Okay, so if you'll notice that this hydrogen actually gets plucked off of here, so it donates that one to that one. Okay, so it donates this to the base. You notice how that this is written as OH negative? It doesn't matter what the ion is on the front of that thing. Because when it goes to the solution, I mean, it could have been NaOH. It could have been KOH. It could have been CaOH with the OH in parentheses and a 2. I mean, it doesn't matter. It's got those ions in the solution because they're strong bases, and when they get into the solution, they separate, right, into ions. And so it didn't really matter. So I could have wrote this one in ions too. Anyway, so our example didn't have that, but so that it just is telling you that this first ion on that thing just was not significant. So that's why that's already in water like that. Okay, so let's go ahead and think about this. So this was donating. So if it donates, then that means it is the acid. That is the definition of a Bronsted-Lowry acid. So it's a proton donor. Now notice this right here is taking it and becoming water. So it's taking that proton, taking that H+, so it is accepting it. Okay, it's accepting it, so that means that that's the definition of what a base is. Okay, so I've showed you kind of two different ways. What the definition is in red here, and then what the some simple ways to finding your answers are in the blue. Okay, let's look at this one. In fact, if I was looking at this one, I'd think like, oh, wow, that kind of looks like sulfuric acid, but it's not. Okay, so this one is sulfuric acid. So with my blue again, this is my acid. Why did I know that this was sulfuric acid and that this one was not? Well, it didn't do, it has an ion there, first of all. So that tells you it's not like the naming of the acids that we've had in the past. Okay, there is another species here that you should recognize too, and that's this guy right here. That's an acid too. Okay, in fact, that'd be our conjugate acid. So, I mean, that's just picking out some species out of these four that I know and I recognize right away. Okay, now let's recognize this also too. This one looks a lot like this one. So these two are pairs. Okay, and these two are pairs. Okay, so even if I didn't have these two marked here and I just had one marked or whatever, I could figure out what all of them are. So since it's a conjugate acid, its base pair is right here. And isn't that lovely? Because this would be an acid and a base. It would never be an acid and an acid or a base and a base. It would always be an acid base. Okay. So then we know, okay, so we get a conjugate acid. Here's its partner. It's a base. Here's this one, acid base pair. Here's its conjugate base. Okay. And so recognize that these are acid-base pairs too. It's just that they're on the right side of the arrow, so that makes them conjugates. So that's just a little bit of information there to check and see how you did on those two problems.